question 8.4 is the sine and cosine ratios. So you may remember that the last section was all about the tangent. So if we needed to fill in what we already know, we know that the tangent is equal to the opposite over the adjacent. And we often just say O over A, so tangent. If we look at the other two, here's what we're going to know. We're going to know that cosine is the same thing as adjacent over hypotenuse. Okay, so we call that A over H. So you can see where we're getting the ka from. Cosine is A over H. You can see where we got the tangent from. Tangent equals opposite over adjacent. And so the last one is the sine. And I know this looks like the word sine with an E on the end, and oftentimes it's abbreviated like this. We still call it the sine. We don't call it the sin. It's a sine. And this is the cosine abbreviation, and then this is the tangent abbreviation. Okay? So sine is equal to opposite over hypotenuse. So O over H. So again, you can see where we get the acronym SOH. So SOHCAHTOA. Okay? It depends which angle you're talking about as to which side of the opposite and the adjacent would go on. Okay? So what we're going to do is take a couple minutes and try this. I want you to label the triangle over here that says hypotenuse. I want you to label it A, B, C. And we're going to call this side Z. And we're going to call this one over here Y. And then we're going to call the hypotenuse X. Okay? And so we're going to do the sine and the cosine and the tangent for all three angles. For both angle A and angle B. So we're going to do the sine of angle A, which is opposite over hypotenuse. So find angle A. The opposite side from angle A is Y, and the hypotenuse is X. So we would do Y over X for the sine. Okay? The cosine of angle A, so now I'm looking at angle A still. The cosine is A over H, so adjacent over hypotenuse. So find angle A. The adjacent side has to be Z because X is our hypotenuse. So the adjacent side is Z, and the hypotenuse side is X. So Z over X is the cosine. And then the tangent of angle A, we should be pro at this one because we did a whole lesson on it already. Tangent is opposite over adjacent. So find angle A. The opposite side is Y, and the adjacent side has to be Z because X is our hypotenuse. Okay, so we did sine, cosine, and tangent for angle A. Now we're going to take a moment and do sine, cosine, and tangent for angle B. Sine of angle B. So the sine is opposite over hypotenuse, so find angle B. The opposite side is Z, and the hypotenuse side is X, so Z over X. We're going to do the cosine of angle B. So find angle B. The cosine is the adjacent over the hypotenuse. So the adjacent is Y over the hypotenuse, which is X. Okay? And then the tangent of angle B. Okay? So the tangent is opposite. So opposite angle B is Z over adjacent. And adjacent to angle B is Y because X has to be the hypotenuse. So hopefully you're able to find those and just kind of identify the opposites and the adjacent sides. That's what that was about, being able to identify those things. And now let's practice it with some numbers. So let's label this triangle. We're going to call it G, R, and T. And the hypotenuse is 17. GR is 8, and side TR is 15. So, sine of angle T. So go ahead and find angle T. Remember that sine is opposite over hypotenuse. So opposite from angle T is 8 over hypotenuse, which is 17. So the sine is 8 over 17. The cosine for angle T. Cosine is A over H, so ka, A over H. The adjacent side to angle T has to be 15 because 17 is the hypotenuse, and we need that for the denominator. So adjacent 15 over hypotenuse 17. And then the tangent of angle T. Tangent is opposite over adjacent, so we're going to do opposite angle T is 8 over the adjacent side, which has to be 15 because the hypotenuse is 17. Okay? So let's do this again, but let's do it for angle G. So sine O over H, opposite of angle G is 15 over the hypotenuse, which is 17. Cosine angle G. So cosine is A over H. So adjacent side to angle G has to be 8 because 17 is the hypotenuse. We need that for the denominator. And then the tangent of angle G, O over A. Opposite angle G is 15 over adjacent, which must be 8 because 17 is the hypotenuse. So that gives you a lot of practice at looking at which angle are you talking about and finding the opposite, the adjacent, and the hypotenuse sides based on that angle. Now let's talk about using the inverses to find the angle measures, because this will give us the relationship of the side lengths, but now we want to find the angle measures. So let's go ahead and scroll the page up. And talk about using the inverses. Okay, so let's label our triangle. We have F, we have L, and O. The hypotenuse is 4, side LF is 2.4, and side FO is 3.2. So let's write something down here. The inverse sine is that you still do the opposite over the hypotenuse is what you do for the sine, but the inverse means that you're using the key with the -1 on it, the inverse of the sine being the O over H. This means the inverse of the sine OH. And then you do the inverse of the cosine AH, and then you will do the inverse of the tangent of O over A. Okay? So let's do this. Find the measure of angle L using the sine. So they're telling us to use the sine for angle L. So if I want the angle measure, I'm going to do the inverse sine of O over H. And so I need to do the inverse sine of, what's the opposite of angle L? So find angle L and look at the side that's opposite angle L, 3.2. What is the hypotenuse of that triangle? That's the side across from the right angle, so that's 4. And then you're going to do 3.2 divided by 4 on your calculator, and you're going to hit equals. And then you're going to do shift and hit the sine key, and you're going to find out that we got 53 degrees. Okay? So now they said, well, go ahead and use the cosine instead to find the measure of angle L. So look, if we're finding the measure of angle L, it should not really matter. Once you find angle L, you know its measure. You can use the sine, the cosine, or the tangent to find the measure of angle L. It doesn't matter. But what I'm proving to you here is, in fact, it doesn't matter. You can choose to use the sine, you can choose to use the cosine, or you can choose to use the tangent. And the reason why you get to choose is because you already know all 3 distances of the sides of the triangle. If you think back to the tree problem that we were doing, we had to find the height of the tree, and we knew how far she had stepped away from the tree, and we knew the angle, but we didn't know the hypotenuse side, and we also didn't know the height of the tree. So we had to figure out, well, what information do we have to figure out which trigonometric sign we needed to use? That's the tricky part when we get into the word problems. So right now, let's do the cosine. Cosine of -1. Cosine is A over H. So the cosine of the adjacent side to angle L is 2.4, and the hypotenuse is 4. And when you do that on the calculator, lo and behold, you get 53 degrees. Let's use the tangent. So the tangent of -1 is opposite over adjacent. So the inverse tangent of opposite to angle L is 3.2. Adjacent to angle L is 2.4 because 4 is the hypotenuse. And again, check it on your calculator, you should get 53 degrees. So now what I'm going to do is just allow you to choose whichever way you prefer to find the measure of angle O. Okay, you can choose whichever one you want to do. You should probably pause right now and try to find the measure of angle O, deciding whether or not you want to use sine, cosine, or tangent. And then press play when you're ready to check your work, and I'm going to show you all three. Okay? So the sine, the inverse sine O over H, and this time again I'm dealing with angle O. So opposite angle O is 2.4. Okay? So 2.4 over the hypotenuse, which is 4, right? And the inverse sine gives us 37 degrees. If you did the cosine, you did A over H, so you did the inverse cosine of the adjacent side to angle O, which is 3.2, over the hypotenuse, which is 4, and you got 37 degrees. If you used the tangent to solve the problem, you did opposite over adjacent, which means you did the opposite side from angle O, 2.4, over the adjacent side, 3.4, or 3.2, sorry. And then when you calculated it, you got 37 degrees. Okay, so you use the inverse sine, or the inverses, when you're looking for the angle measures. Really important. Inverses when you're looking for angle measures. All right, the only other thing in this lesson is about proving some of these rules to be true. So proving sine, cosine, and tangent identities. Here's how you do this. You're going to be changing one side to its ratios. Change one side to its ratios. Okay? And when I say ratio, ratios, I mean opposite over adjacent, or adjacent over hypotenuse, or opposite over hypotenuse. You're going to be changing the words tangent and cosine and sine into their ratios instead. And then you're going to simplify. Okay? And the goal is to get both sides to say the same thing. We want both sides to be equal. And so typically we would leave the left side alone. We're going to leave the left sides all by themselves, and we're going to change the right-hand side to equal what the left-hand side is. So I want to simplify cosine times tangent all the way to the bottom until it says sine of x. Okay, I want them to equal each other. So here's what I'm going to do. I'm going to change these all to their ratios. So the sine is opposite over hypotenuse. I'm not going to worry about the x's right now. And then I'm going to say the cosine is the adjacent over the hypotenuse, and I'm multiplying that times opposite over adjacent. And so I have to look at this multiplication and how I can simplify that in some way. So I hope you notice that you have a in the numerator and a in the denominator. Anytime you have anything divided by itself, you get 1 as your answer. So I'm just going to drop down my OH over here, and then I'm going to simplify. O over H. So O over H is your sine. So I just got it to say sine x equals sine x. So it's true. Okay, I proved that the cosine of x times the tangent of x is equal to the sine of x. So just prove that to be true. All right, let's look at the second example. Tangent is opposite over adjacent. the sign, which is in the numerator of this fraction, is opposite over hypotenuse. And the denominator, which is the cosine, is adjacent over hypotenuse. So now this gets a little tricky. When you do division of a fraction, let's say I had 1/2 and 3/4, right? 1/2 divided by 3/4. You learned in middle school that if you needed to get this, you need to get a fraction out of the denominator. And how you get rid of a fraction is multiplying it by its inverse, right? And if you do that to the denominator of the fraction, you have to do it to the numerator of the fraction. So we discovered that every single time what was happening was we were flipping the 3/4 into a 4/3. So we were flipping it and multiplying. Every time, flip and multiply. That's how you got rid of those fractions. Flip and multiply. So we're going to do the same thing here. Whenever you have a fraction within a fraction, you take this one, you flip it, and you turn it in to a multiplication sentence instead of a division sentence. So flip and multiply. When we do that, you can see that the h's are going to cancel. We're going to have O over A is equal to O over A. O over A, opposite over adjacent, is the tangent. So the tangent of x equals the tangent of x. And again, we got that one to prove out. So you're going to have a couple of those to do at some point. You want to make sure you're practicing how to do those. There's a few of them that we can give you for extra practice if you need them, so just please ask.